Good morning, class. Here's module 1, covering chapters 1, 2, 3. Here's chapter 3, describing, exploring, and comparing data. The following data gives the number of hours that a few, and that's really a key, employees at the GM factory worked last week. 17, 38, 27, all the way to 25. We want to find the mean. Ranked data, there are 18 pieces, and we put them in order from smallest to largest. The first one is number 14. The second one is number 16, and we go all the way to the last one, 18, which is 42. What I want to make a point of is the following. We don't need to rank data for some calculations, such as finding the mean, because in order to find the mean, just add them up, divide by size. However, it's a good practice to do so for those calculations that need ranked data. Later on, when we look at other parts of this question, we see that ranking is a must. In order not to make a mistake for those parts, I highly recommend you do that. If it has only this part, find the mean, you don't have to rank. So we use the formula x bar is summation of x over n, which starts from the first one, number 14, and then plus 16, and all the way to 42, divided by total size 18. Now, why did I say FU is important? This refers to the fact that it's a sample. It's not a population of employees. It's not all employees. So we use X bar. As far as the notation is concerned, we use X bar for sample, mu for population to represent the mean. So add them up, divide by 18, and 485 over 18. Notice I have 4 decimals. As far as the number of decimals is concerned, sometimes if they don't say rounded, you just keep on writing a few more, or you write the exact fraction. Of course, this has to be simplified if you can simplify. I hope everybody is clear. If not, that's the exact answer. That's one way to do that. The next one is find the mode. Remember, in this case, there is no mode. Why is that? Because when you look at these numbers, none of them repeats. As you recall, mode is the one with the highest frequency of occurrence. If any number repeats, the highest number of repetition results in the mode. So it has to do with the definition of a mode. Median. Well, there are 18 pieces. Median is the middle of the data. When you have ranked data, the number in between. So there is no number in between. The number in between is here, is between 9 and 10. So that's why, because this is 18, you divide it by 2, and the number is odd, you go in between, you add 25 and 27, and divide it by 2. So the median, x tilde, 25 plus 27, divided by 2 is 26. Find the mid-range. By definition, mid-range is minimum and maximum, add them up, divide by 2. So mid-range is the value midway between the max and mean, therefore has the formula add up the 2. And this is very important. If it wasn't ranked, we would make a mistake of thinking, for example, 17 is the minimum, 25 is the maximum. That's why you sort your data. So 14 and 42. In this case, the max is 42, the minimum is 14. Add them up, divide by 2. The answer is 28. The next one is find the range. By definition, range is max minus mean. So the largest number minus the smallest number is 28. Now, what I want to emphasize here is the following. Note, R and MR, that means range and mid-range, are not equal in general. In this case, it just happened by chance. I want to emphasize that. Going to continue with the same question, and now we want to find the variance and the standard deviation. I remind you of the formula. You're dealing with a few, you're dealing with a sample. The formulas for sample variance are as follows. S squared is summation of x minus x bar over quantity squared over n minus 1, or n summation of x squared minus summation of x quantity squared over n times n minus 1. And I'm going to show you both because I want you to understand the concept, how to calculate it. If you happen to calculate it by hand, nobody expects you to do this by hand. But if there are just a few, 3, 4, maybe 5 pieces of data, you should be able to handle it. So here's the process. If I'm going to show you both formulas, if we go with this n, remember n is 18, right? There are 18 pieces. Summation of x squared. So that means the first one squared plus the second one squared plus the third one. And I'm going to choose the ranked ones is easier. And then summation of x squared, that means add them up and to the second power. So let me write this so it becomes clear. N is 18. Then summation of x squared means 14 squared plus 16 squared plus 17 squared all the way to the last one, 42 squared. Minus summation of x quantity squared, summation of x, parentheses, 14 plus 16 plus 17 all the way to 42 quantity squared, and divided by n, which is 18, n minus 1, which is 18 minus 1 or 17, and it ends up being this number. Now, this number is very close to 75. So if they said, let's say 6, 7 decimals, of course, you have to write them. But if it's less than that, it ends up being 75.000, simply 75. And that's fine. I want to show you how to use this one and the meaning of this summation of x minus x bar. Remember, we calculated the x bar as 26.9444 in the previous page. So according to this formula, each piece 14 minus this number and square it. Each piece of data 16 minus this number and square it. All the way to the last one, 42 minus this number and square it. Add them up. This is the numerator, everybody. So I'm using this formula. And again, it means each piece of data, subtract from it x bar. And the reason it doesn't matter in what order you do that, because being squared divided by n minus 1, which is 18 minus 1, and it gives you that. If you mix them up with the population variance, this would be capital. Now, the standard deviation is just the same thing, take a root. So this part is very easy. And this one, I'm showing you a different method to come up with 75. So standard deviation, simply take a root of that. So you show work for a squared, and then S is easy. Inner quartile range, or IQR. The IQR describes the middle 50% of values when ordered from lowest to highest, or Q sub 3 minus Q sub 1. So this one is Q sub 2, or median, 25 plus 27 divided by 2, or 26. Now, in order to find Q sub 1 and Q sub 3, so this is exact. The other have different formulas, and if you use different technologies, you may come up with slightly different answer, okay? However, if you have a large set, they end up being the same. As far as you show your work, you get 4 credit. Either way is fine. And one easy way is to cut this into 2 pieces. So the bottom piece is this, the first 9 on the left, and the middle of that, the 5th one is number 20. And Q sub 3, the top half, the middle of that is number 14. The 14th value is 34 for the rank data. So this is one easy way. So I'm going to repeat that. The median is easy to calculate. Just the middle of the data. If it's an odd number, by the way, you just have one number in between. If you have an even number, there are 2 of them, you find them. And then the bottom half, the median is Q1. The top half, the median is Q sub 3. Now again, the interquartile range by definition was Q sub 3 minus Q sub 1. So 34 minus 20 or 40. It is important to know this. You need to understand the concept. However, it's mostly done by technology, especially if you have quite a few, in this case, 18 values. So we have the formula for the sample variance. We have X bar S, Q sub 1, Q sub 2, Q sub 3. All of them are calculated already. But I want to show you how it works with the technology. If you want to use a TI calculator, first, you go with stat clear list. You pick a list such as L1, edit, type in data, and then see what happens. So first and foremost, you are going to use, for example, if you're using a TI calculator, you edit, so you go to stat clear list. So you are going to edit. Down here, you are going to clear the list first, and you choose a list. If the list hasn't been used, you don't have to clear it. But just to be on the safe side, first clear it. Then you edit, okay, and you put in the numbers. So I put the numbers the way I received it. Okay, 1738 all the way to the end. Then we move this to calculation. And we move to calculation. The first one is one variable stats, so on and so forth. We go to the first one. We choose the first one. And when we choose the first one, it gives us L1. If you want to change it, normally we use L1. There are normally 3 or 4 lists. So L1 comes automatically, so you don't have to do anything, just press enter. And it gives you some information. The arrow means go down and gives you more. So let's see what we received from our calculator following the instruction here. You can also find it under the last module in Canvas, the TI commands. Let's see what we have here. First, this was the X bar we calculated. This is the X bar they give us. Second, this was the standard deviation we calculated. This is the standard deviation. Please pay attention to S sub X versus sigma sub X. They do calculate both of them. This is for the population. Remember, I told you when it says a few employees, that's important. That refers to a sample. Because for population, this is capital N, everybody. So that's why they don't know which one you need. They give you both. You want S sub X, not sigma sub X. Of course, it's giving you N equals 18. And then take a look at what we have here. Q sub 1, Q sub 2, Q sub 3, and you have Q sub 1, Q sub 2 or the median, and Q sub 3. Also, you have the minimum, 14, maximum, 42. So the fact that you have this information, it could help you find the range, for example. So it has done just about everything that you need to do. We're going to continue with the same question, the same information. And if you were to use an Excel to do the math, again, I give you some of the commands as I come across them. So the Excel commands sort, input and select the data range. Click on sort upper right corner, sort A to Z or Z to A. This is something most students have already used. So you put the data somewhere, and then, so this is hours, this is the data. You choose the data and you click sort from A to Z, and it gives you what we just have here, sorted data. The next one, the commands is descriptive statistics, mean, median, mode, standard deviation, so on and so forth. So make sure data analysis pack is added. This is for those who use Excel and they are somewhat familiar with that. To data analysis, descriptive statistics, you input the range, you choose the range from here to here on your cell, let's say 2 to cell 19, whatever. Check mark label in the first row, so you want the label in the first row. And check mark all you need. Output range, pick a cell somewhere, put it somewhere, and just enter it. So it looks something like this. So input range, when you can put it here or just, highlight them. Okay. Label in the first row. Okay. You want them in column format. You can have in a row format also, but it's easier to put it in column format. You want summary statistic. Okay. And output range, you just click somewhere and you press this is okay, and it will show everything you want as follows. So notice what it gives you. It gives you a lot of information. We are interested in the mean. That's what we had here. This is calculated by Excel. We were interested in standard deviation. We have it here. A range, I hope you remember the range was 28. The minimum is 14. The maximum is 42. These are the pieces of information that we receive. Now, what about the rest? Now, for Q1, Q2, Q3, click any blank cell and type. For example, for Q1, just input the range, okay, that you want. And you put from this cell to that cell, and then 1, that means Q1. If you put 2, that means Q2. If you put Q3, that means, if you put 3, that means Q3. If you put 0, that means find the mean. If you put 4, that means find the max. So as an example, you put quartile from D65 to D82, for example. You can try this. In fact, if you put this in D65, D82, comma 1, it generates this number. Q2 is this one, Q3 is that one. Notice there, Q2, of course, that's between 25 and 27, obviously it's 26. But Q1 and Q3, they are calculated differently, and that's my point. It doesn't matter which technology you use. If you understand the concept, you get full credit. And more importantly, if the data is large, then there is no discrepancy between the two. IQ scores have a mean of 100 and a standard deviation of 50. Find the coefficient of variance. It's very important to understand the given. So mu is 100, sigma is 50. Notice we use Greek letters for population parameters. So this is mu because it pertains to all, and this is sigma. Okay. IQ scores have a mean. It doesn't say which sample size. So that means in general. Coefficient of variance. Here's the definition. The coefficient of variance, or short CV, describes the standard deviation relative to the mean and is used to compare standard deviations when the units are different. Normally, that's when we use them. So with that being the case, in this case, it's just a simple case of 15 over 100. And that's the answer. You can simplify into a fraction, but because we are representing it as a percentage, it's just 15%. Use the range rule of thumb to estimate the minimum and maximum usual IQ scores. So range rule of thumb and usual. According to stats, range rule of thumb means mu plus minus 2 sigma or x bar plus minus 2s, meaning start from the mean, go 2 standard deviations to the right and 2 to the left. You start from the mean. 2 times the standard deviation 15 is 30. So you go 100 plus 2 times 15, also 100, minus 2 times 15. So mu minus 2 sigma is 100 minus 30, or 70, and plus 2 sigma is 130. So it's from 70 to 130. That means within 2 standard deviations. So in essence, the concept is this. Here's mu. We go mu plus 2 sigma on the right, mu minus 2 sigma on the left, and it gives us from 70 to 130. That's the idea. That's called the range rule of thumb, because normally 2 standard deviations is good enough, especially in the case of an empirical rule that I'm going to go over in a moment. Using Chebyshev's theorem, find what is the least percentage of those who will have an IQ score of 70 to 130. We're going to do exactly the same thing, but this time using empirical rule to find the percentage of those who will have an IQ score of 70 to 130. Chebyshev's theorem applies to just about any distribution we don't have any information about. And the proportion of values from any data set that fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is the number greater than 1, k is not necessarily an integer. And from 70 to 130, we know it represents 2 standard deviations. That means k is 2. So k is 2, since 130 minus 70 is 60, or 4 sigma, k is the number of standard deviations away from the mean. So 1 minus 1 over 2 squared. And as you know, 2 squared is 4, 1 over 4, 1 minus 1/4 is 3/4. 3/4 also is the same as 75%. At least 75% have an IQ score of 70 to 130. So this is according to Chebyshev's theorem. Empirical rule gives us the following. If you start from the mean and you go 1 standard deviation away on each side, it gives you about 68%. If you start from the mean and you go 2 standard deviations away on each side, it gives you about 95% of the data. And that's why the range rule of thumb, dealing with in conjunction with empirical rule, deals with 2 standard deviations, because 95% of data is good enough for most everybody. And from the mean, if you go 3 standard deviations to the left, 3 standard deviations to the right, you cover almost everything, 99.7%. We need to know those 3 numbers. And in this case, we know from 70 to 130 is 2 standard deviations away. The answer is 95%. So 95% will have an IQ score of 70 to 130. 70 to 130 are 2 standard deviations away from them. Number 3, given the data 32, 19, all the way to 50. Rank the data from the smallest to largest. Prepare a box and whisker plot. In order for you to do part B, you must do the first part anyways. In other words, they don't have to ask you to do that for you to come up with that. This requires sorting data from smallest to largest. So the smallest one is 3, the largest one is 50, and we go in order. Now, a box whisker plot has a few pieces of information. It has the minimum, it has the maximum, and it also has Q sub 1, Q sub 2, and Q sub 3. So let's cut this into 2 pieces. So there are 14 pieces of data. Again, we have an even number. So the number in between, so you really have to add these 2 and divide by 2, which happen to give you 15. So Q sub 2 or median is the sum of these 2 divided by 2. 15 plus 15 divided by 2 is 50. There are different ways of calculating Q sub 1 and Q sub 3. One is what was mentioned to you. So this one, this bottom half, 1, 2, 3, 4, 5, 6, 7 pieces of data. The one in the middle is 7. So that is Q sub 1. This one, 1, 2, 3, 4, 5, 6, 7. Again, the one in the middle is 19. Very easy, the way we have done it before. I want to show you different ways as well. And I want to discuss those. But so you already know the answer in essence. So we go with the locator. And we know there are 14 pieces of data. L is K over 100 times N. Remember, Q sub 1 refers to the bottom 25%. So the K for Q sub 1 refers to 25. For Q sub 2 refers to 50. We don't have to worry about it. We already have that. And for Q sub 3 refers to 75%, therefore 75. And so for Q sub 1, 25%, replace this with 25, and it gives you 3.5. The methodology is that you have to go with the next piece of data, you round up, and you get the fourth piece. So we have the first, second, third, the fourth piece of data, Q sub 1 is 7. For Q sub 3, it's the 75th percentile. So K in this is 75. Or simply, you don't have to go there. You can say 0.75 times N. N happened to be 14. 10.5 rounded up to 11. So the 11th one, remember there are 7 here. 8, 9, 10, 11. And we got those values. Now, it's really a good practice to have a number line and put those values from the minimum, which is number 3, to maximum, which is number 50, and Q1, Q2, and Q3. So let's say those, when we do that, they are fairly to scale. So we have number 3 here, number 7, 15, 19, and the largest value is 50. And the concept of a box and whisker plot is that Q sub 1, Q sub 2, and Q sub 3, Q sub 2 or median, they give us the box. And from here, we go with it like a whisker, the tail to the minimum, and this one, the tail to the maximum. And it looks like this. Therefore, the name box and whisker plot. Here's the box. and here's the tail. So inside the box, the left side is Q1, the right side is Q sub 3, and we pinpoint the median. Then the minimum is connected with a line to the box, and the maximum is connected with a line to the box. So we should be able to tell from the whisker plot, the box and whisker plot, what's the minimum, Q1, Q2, Q3, and maximum. And from the minimum Q1, median Q3, and maximum, we should be able to set up a box and whisker plot back and forth. We're going to continue with the same question. The question is, does this data set contain any outlier? Make sure to show the lower and upper fences on your graph. So let's look at the concept of an outlier. Here's the definition. First of all, an outlier, that means something that is out there, it's way out. But in statistics and in math, we want to be solid. We make up an equation. The value for Q sub 1 minus 1.5 times IQR and Q sub 3 plus 1.5 times IQR are the fences that mark off the reasonable values from the outlier values. Outliers lie outside the fences. So let's calculate IQR. We already have Q sub 1 and Q sub 3. We calculate the difference. 19 minus 7 equals 12 is the IQR. We're going to multiply by 1.5. 12 times 1.5 is 18. The data is considered an outlier if its value is less than Q sub 1 minus 1.5 IQR. 7 minus, we've already calculated this, minus 18. So any number less than negative 11 is considered an outlier. So when you look at rank data, you don't see that. So you don't have an outlier on the left side. And now let's look at the right side. Or its value is larger than Q sub 3 plus 1.5 IQ, or Q sub 3 is 19 plus 1.5 IQR, that means 18, that gives us 37. Now, do we have any number larger than 37? The answer is yes, and that is number 50. So do we have an outlier? Yes. What is that? 50. Now, I want to add that a data is considered an extreme outlier if its value is less than Q sub 1 minus 3 times IQR. Instead of 1.5, instead of 18, we use 36. So 7 minus 36 or minus 29. And also if it's larger than Q sub 3 plus 3 times IQR. So either or. In this case, Q sub 3, 19 plus 36, making it 55. So we don't have extreme outliers, but at least I wanted you to be exposed to the concept. We're going to continue with the same question. Are the data symmetric or skewed? If skewed, are they skewed left or right? We have Q1, Q2, Q3. We have the data. We have the mean. We have the max. We have the box and whisker plot. So let's see what happens. Note 1. Make sure the drawing is to scale. If it's not to scale, it may not give us the proper answer. What else? Note 2, skewed data show an uneven box plot, in which case the median cuts the box into two unequal pieces. Longer part on the right or above the median indicates data is skewed to the right or positive skew. That means the mean is larger than the median. Longer part on the left side or below the median indicates data is skewed to the left or negative skew, or the mean is less than the median. Note number 3. Sometimes the box may look even, as it is the case here, almost the same, almost. Or uneven, and even skewed to one side. However, the whiskers, those tails, those lines on each side of the box may indicate otherwise. Therefore, pay attention to both. So take a look at how you figure this out. So you draw a line, you have Q sub 2, and you look at this line versus this line. Clearly, this part is longer. So it's skewed to the right. It's skewed to the right or positive skew. The mean is larger than the median. Draw the box and whisker plot for the following data. First and foremost, we should rank it. It is ranked already. Sometimes they give us ranked data just to, save time. So we have the minimum, we have the maximum. Now we need to find Q sub 1, Q sub 2, and Q sub 3. So we cut it into two pieces. The median is in between these two. So 86 and 87 divided by 2, or 86.5. The bottom half has 4 pieces. The median is between these two numbers. So there are different ways to calculate Q sub 1 and Q sub 3. Here's an easier way. This splits the, I've already mentioned that to you. The list into two halves, 77, 79, 80, and 86, and 87, 87, 94, 99. Since the halves of the data set each contain an even number of values, the sub-median will be the average of the middle two values. So this one, 79 and 80 divided by 2, and this one, 87 and 94 divided by 2. So Q sub 1 becomes 79.5, and Q sub 3, 87 plus 94 divided by 2 is 90.5. So what are the numbers? The 5 number summary are the minimum, 77, Q sub 1, 79.5, Q sub 2, 86.5, Q sub 3, 90.5, maximum is 99. And you have a scale, and you do your best to put this in a proper scale. Otherwise, you can't tell what's going on. So this is the whisker plot again. Notice we have the minimum, we have the maximum. The box contains 3 parts. The left side is Q1, the right side is Q sub 3, and the median is some number in between, happen to be 86.5. Now, from Q2, if we draw a line from Q2, you notice the left side and the right side almost the same. So data is almost symmetric. That's why they call it normal or bell shape. So if you were to graph, it looks like this. Symmetric, normal, bell shaped. Now, just in case, if we were to find IQR is Q sub 3 minus Q sub 1, we have the values, which is 11. And Q sub 1, 79.5, minus 1.5 times IQR, Now 1.5 times 11 gives you 16.5. That gives us 63. So a value below this number is an outlier, or Q sub 3 plus 1.5 times IQR, that means 90.5 plus 16.5, 107. And extreme outliers, if it's 3 times IQR, so Q sub 1 minus 3 times IQR, and make sure you do the calculations, 46.5, and Q sub 3 plus 3 times, that is 121.5. My point being, if they asked for outliers, we can calculate them. So a number less than 63 is an outlier. We don't have it here. A number larger than 107 is an outlier. We don't have any outliers. Note what happens if n is odd. Okay. So what I did, I wrote the same thing and I made up one more number just in case I want to show you something. Clearly, Q sub 2 or median is 87. So that's not a big deal. Now, how do you find, with this methodology that was mentioned, the submedians? How do you find them? Well, for the bottom half and the top half, in some instances, and in most cases, they include this 87 for the bottom half as well as top half. In some cases, they don't include it for any of it. And again, it does make a huge difference for a small piece of data. But if you have a large set of data, it makes no difference whatsoever. So, sorted lowest half, including the median, the answer is 80, the middle one. Sorted highest half from 87 to 103, the middle one is 94. Again, odd number of values, median is the middle one, Q sub 3 is 94. Again, there are different methodologies of calculating this. Answer the following. If the mean of a set of data is 23 and 12.6 has a z-score of negative 1.3, then the standard deviation must be what? That gives us the fact that we have to use z equals, first, mu is given as 23, x is 12.6, and z is negative 1.3, and we are looking to find sigma. So the formula is z equals x minus mu over sigma. And you can do the cross product, or you may notice when you have a case like that, you can interchange. You put the sigma here, z here, and now plug in. That's why it's important to write the given. X minus mu, 12.6 minus 23 over z, which is negative 1.3, and that results in 8. Therefore, the answer is D. So you answer with justification. Part B, find the z-score for each student and indicate which one is higher. Art measure, AM for short, theater measure, TM for short. The value that the student has received is 46, for theater measure is 70. However, for the art measure, X bar, the mean is 50, the standard deviation is 5. For the TM or theater measure is different. X bar is 75, the mean, and S standard deviation is 7. And so for each one, we calculate the Z and we compare the Z score to answer the question. Z is X minus X bar over S. So for AM, X is 46 minus X bar, which is 50 over 5, gives you negative 4 over 5 or negative 0.8. By the way, if the z is 0, that means it's identical to the average. In other words, if this was the same as 50, this would become 0. If this is larger, z becomes positive. If it's smaller, z becomes negative. So negative score on z doesn't mean it's a negative score. It means it's lower than the average. Positive means above average. 0 means identical to the average. We do the same thing for TM. x minus x bar, so 70 minus 75 over 7, and this happened to be negative also, minus 5 over 7. We put it in decimal so we can compare. Negative 0.7143. Both of them are below average, but this one is more negative than this one, and that makes it part C. The theater measure has a higher score than the art measure. So this is a better score than this one because it's less negative than this one. None of them is good. Both of them are below average. Answer the following if the 5-number summary for a set of data is given as 0, 3, 6, 7, and 16, then the mean of this set of data is definitely part B. There is insufficient information to calculate the mean. Why is that? Well, the formula x bar is summation of x over n. This is for the sample, or mu equals summation of x over capital N for the population. We need to add up all values in the data set and divide by the number of values. That means we need all data. We need each and every piece of data to do so, and we don't. Which of the following is true? Well, the answer is B. The question is why. Let's go over some definitions. Decile, short D. So D5 means the 5th decile. Deciles, by definition, a decile measure, it's measures of location that divide the data into 10 equal parts. 10 equal parts. Percentiles, or short P, measures of location that divide the data into how many? 100 equal parts. Quartile, for short Q, measures of location that divide the data into 4 equal parts. Therefore, D5, P50, and Q2 are identical according to this definition. A student received the following grades: an A in statistics, 4 credits, an F in physics 2, 5 credits, a B in sociology 3 credits, a B in a literature seminar 2 credits, and a D in tennis 1 credit. Assuming A is 4 grade points, B is 3 grade points, C is 2 grade points, D is 1 grade point, and F is 0, the student's grade point average is, we have to calculate the GPA, and it's important for students to know that we use weighted average or weighted mean. And it makes a perfect sense because if, for example, A happens when you have 5 units and D happens when you have 1 unit, this will take over. This is much heavier. So how do we calculate that? When different X data values are assigned different weights W, we can compute a weighted mean. To find the weighted mean of a variable, multiply each value by its corresponding weight and divide the sum of the products by the sum of the weights. So A, F, B, B, D. A was 4 units. F was worth 5 units. Then we have B 3 units, another B 2 units, and another D 1 unit. And we know A is worth how many points? 4. F is worth 0. B is worth 3. This one also 3. D is worth 1. So in short, we are going to multiply this column by this column and divide by the weights. So the formula is x bar is W1 x1 plus W2 x2 all the way to the last one over the sum of the W's. We put the sum of W times x, that means 4 times 4 plus 5 times 0, 3 times 3, 2 times 3, 1 times 1, add them up, that means the top, over the summation of W over the total weights, add this up. So 4 times 4, 5 times 0, 3 times 3, 2 times 3, 1 times 1, and add up 4 and 5 and 3 and 2 and 1. You get 32 over 15 or 2.133. Normally, they want you to report it with 2 decimals, but pay attention. If they say 2 decimals, 3 doesn't change because this number is 3. Remember this, if this is 5 or larger, this changes. So you want to be very careful with your round. Given the data set 10, 44, 55, 23, 14, 18, 72, find the 56, find the value that corresponds to the 75th percentile. So we want to look at this slightly different. First, we are going to rank the data. And then we want to explain this concept. Again, we've gone over this. Remember, in this case, n is 8. You count, there are 8 pieces of data. And here's the locator, if you will. The location is L equals K over 100 times N. So when we say 75th percentile, K is 75, or you can say this is 0.75. That has the same meaning, class. So let's use that to find 75th percentile. So when we multiply the two, we get number 6. Now, the methodology is that if you come up with a whole number, since 6 is a whole number, you go to the next one also and you find the median for the 6th and 7th, the mean of the two numbers. The 6th one, okay, and the 7th one. 1, 2, 3, 4, 5. The 6th one is 44. The 7th one is 56. Add them up, divide by 2, and you get 50. Whenever it's a whole number, that's the process. 30th percentile, we do exactly the same thing. Here we replace the K with number 30, or just say 0.3 times N, which is 8. 0.3 times 8, and it gives you 2.4, or 30 over 100. So the 2.4th piece of data. Anytime you don't have a whole number, you must round up. It doesn't matter, it's 2.1, 2.2, 2.9. It becomes the third one. Becomes 1 to the third one. You round up. Always you round up to the nearest whole number. The nearest whole number. Find the percentile corresponding to number 44. By definition, you look at the number of values less than 44 and you divide it by n. So locate 44. Less than that, 1, 2, 3, 4, 5. There are 5 pieces less than that, and we know n is 8. This is your answer. Just change it to a percentage. That's the idea, everybody. So when you change it, becomes 0.625, so you round it accordingly. So this becomes 62.5% or about 63. So you put P63. Normally they want a whole number here. Using range rule of thumb, estimate the standard deviation. Well, I hope you remember what we said about the range rule of thumb, which was mu plus minus 2 sigma or x bar plus minus 2s. Everybody remembers that, right? Recall, range rule of thumb, mu plus minus 2 sigma or x bar plus minus 2s. Range rule of thumb for estimating the value of standard deviation according to this is to roughly estimate the standard deviation from a collection of known samples. Use s equals range divided by 4. Remember, from the mean, 2 standard deviations to the left and right, that means total of 4 standard deviations. So if you find the range, which is maximum minus minimum, and divide by 4, that is roughly your standard deviation. So max minus mean is the range. In this case, 72 minus 10 divided by 4 is 15.5. This is a rough estimate, range rule of thumb. Here's the last question. The following data representing numbers of keyboards assembled for a sample of 25 days in a company. So those are the numbers. Construct a frequency distribution table with 4 classes. In order for you to construct FDT for short, FDT, frequency distribution table, first you have to rank your data. So you want the number of classes normally you decide. It's been given to us so everybody comes up with the same answer. You need to find what is the width roughly. So you calculate the width by dividing the range by the number of classes. Now, what is the range? So the width is range divided by number of classes, and it's always rounded up, and I'll tell you why in a moment. So range would be 56 minus 41 divided by 4 gives you 3.75. The reason you round up, because you want to cover every piece of data. If you keep it as 3.75 precisely, and you use 41 as the first piece, 56 as the last piece, you get all of them, but it's very difficult to deal with 3.75 as a bit. That's why you round it up to the nearest whole number, and the width becomes 4. It so happened these two numbers are the same. It doesn't happen that way. So how do we come up with the frequency distribution table? The lower limit of the first class you decide, that would be your starting point, and it has to be a convenient number less than or equal than the smallest value, such as 41. The smallest value is 41. You can go with 41 or a number less than that, which would be a convenient number 40. The thing is, when you use the width 4, make sure the number that is the smallest, it has to, when you're done with your frequency distribution table, this number must be in. And I notice if I do 40, it won't be, but you can give it a shot. If you use 40, see what happens. I highly recommend you do that. So if we use 41 as the first limit, meaning the lower limit of the first class, what are the rest of them? We're going to figure them out in a moment. We know the width is 4. So remember, the way to calculate the limits, if you go consecutively, 41, add 4, add 4, add 4. If you go this way, what happens? The upper limit minus lower limit plus 1 unit. Okay? The upper limit minus the lower limit plus 1 unit is the width. So it's easier to go this way, 41, 45, 49, 53, you're adding 4. And over here is 340. And you can calculate it, as I say, upper limit. Let me just write the formula for you in case if you want it. If you want to find this using this formula, upper limit minus lower limit plus 1 is the width. So upper limit minus 41 plus 1 is the width, which is 4, and you end up with 44. So this becomes 44, and then keep on adding 4. Notice this is 44, add the width, and notice the last number is 56. So that's the reason I started with 41. If you go with 40, 56 won't be there, class, because 40, this one ends up being 55. That's why. All right, so how many are from 41 to 44? So since they're ranked data, it's easy to see 41, 42, 43, 44, 44, and not 45. So you can write them in this manner. And you see this one is 1, 2, 3, 4, 5. So I put 5 here. This one is 1, 2, 3, 4, 5, 6, 7, 8 here, and the rest. So this is frequency distribution table, FDT. same question, we want to use the data to find the mean. We also want to find the mean through using the frequency distribution table, or FDT, compare and contrast. Okay, so first and foremost, to find the mean exactly, you need the data. Just add them up. X bar is summation of X, divide by N. So 45, and the next one 52, all the way to the last one 42, divided by however many, there are 25 of them. We end up with the exact mean 48.48. But what if you have a frequency distribution table? It doesn't mean that we have the data. When you have this one only and you don't have this one, what do you do? We use X bar equals summation of F times X sub M divided by N. What do we mean by that? FDT, frequency distribution tables. FDT doesn't give us every piece of data. So we use X sub M, which is the midpoint of each class, to calculate this. So what do we do here? We calculate the midpoint here. Remember, the midpoint is the lower limit plus the upper limit, divide by 2, 41 plus 44 divided by 2. So the first one is 42.5. The rest of them you don't have to calculate. Remember, recall the width was 4. Just add 4. You get 46.5, 50.5, 54.5. So this formula says, according to the frequency distribution table, I don't know what the data is here, but I'm going to assume each one is equal to 42.5 roughly. Over here, I'm going to assume it's 46.5 roughly, so on and so forth. So if I want to calculate the mean using this, I'm going to say, well, 5 of this, 8 of that, 8 of that, 4 of that, add them up and divide by the total size, which is still the same number, 25. So 5 times 42.5 plus 8 times 46.5 plus 8 times 50.5 plus 4 times 54.5 divided by 25. And notice this is the number. The question is, are the two means reasonably close? Look at this number and this number. The fact is we don't have each piece. It's extremely close. So that does a great job. Yes, they are reasonably close.